Hello everyone, let's continue with our revision of the AS level mathematics, and also this is 2024 paper. So as you can see, this is question 8. Figure 3 shows a sketch of a curve C with the equation y equals x cubed minus 14x plus 23. The line L is tangent to C at the point A, also shown in figure 3. Given that L has the equation y equals minus 2x plus 7, show that using calculus that the x-coordinate of A is 2. So let's start doing this question. As we can see, the tangent line L, y equals minus 2x plus 7, has gradient equals minus 2. That means if we differentiate the function y, the curve function y, with respect to x, which give us 3x squared minus 14x plus 23, then that should give us minus 2. Then for this kind of equation, we can find x values. So let's see, 3x squared minus 14x plus 23 equals minus 2. That leads us to 3x squared minus 14x plus 25 equals 0. So we know the gradient of the tangent line is minus 2. That means if we differentiate y with respect to x, then we have 3x squared minus 14. That should equal to minus 2. So if we solve this equation, 3x squared minus 12 equals 0, then we know that 3x squared equals 12, x squared equals 4, and x equals plus minus 2. And since in the figure 3, we can clearly see that A, the x-coordinate of A is positive, therefore x equals 2 is the coordinate of A, of a point A. Okay, that finished part A. So how about part B? Verify the x-coordinate of B is minus 4. Then we need to plug in the L equation into the curve C equation. That means for y equals minus 2 plus 7, we need to replace that with minus 2 plus 7. Minus 2x plus 7 equals x cubed minus 14x and plus 23. Okay, so now let's rearrange this cubic equation that gives us x cubed minus 12x then plus 16 equals 0. And as you can see, x equals 2 is already a root of this cubic equation because the curve intersect with the tangent line at A as well. That means we can actually divide the whole polynomial x cubed minus 12x plus 16 by x minus 2 to see what we have left. So the first bit, you need to x squared times x squared. We have x cubed minus 2x squared. Then do the subtraction. We have 2x squared. We have 2x squared, take away 12x. Then the next bit, we need to plus 2x. That gives us 2x squared minus 4x. Do the subtraction again. That gives us minus 8x plus 16. That means we have to minus 8. That gives us minus 8x plus 16. 0. So therefore, x cubed minus 12x plus 16 can be written x minus 2, x squared plus 2x minus 8. So let's just write this properly. X cubed minus 12x plus 16 can be written as x minus 2 times x squared plus 2x minus 8. And for the x squared plus 2x minus 8, we can factorize this equation, make it equal to 0. We have x plus 4 and x minus 2. Okay, minus 2 is actually point A because it's double point, double root. And therefore, the point B will have x coordinate minus 4. As you can see, we need to prove x coordinate of B is minus 4, then we proved it. Okay, now let's move on to part C. Part C says you need to find out the finite region that's in the figure, so bounded by the tangent line and the curve, and we need to prove that the area is 108. So take a look at this graph as sketched here. As you can see, the enclosed area with the curve of the x-axis will be represented with the red lines, and we need to also find the area represented by the green lines of this trapezium. Once we take away the green area from the red area, we can have the blue area, which is exactly what we're looking for. So first of all, we need to actually find the enclosed area with the curve and the x-axis. So we need to integrate the original function, which is integrate from minus 4 to 2x cubed minus 14x plus 23 dx. That gives us x power to 4 over 4, take away 7x squared, and then plus 23x. And then we need to calculate this result from minus 4 to 2. So first we plug in x equals 2. That gives us 16 over 4. Take away 7 times 4, and then plus 23 times 2. Then take away, because minus 4 power to 4 give us 256, and take away 7 times 16, and then plus, or we say minus 23 times 4. Now let's calculate what do we have now. 16 over 4 give us 4, and take away 28 plus 46, then take away, inside the bracket we have 64, take away 112, and take away 92. Okay, so let's just simplify this. We have 46 plus 4 give 50, 50 take away 28 give us 22, and then we take away and 64 take away 112, that gives us 48, and give us 48 minus 48 minus 92 give us 140, and because that's minus, so plus 140. That is put together 162. Okay, so 162, we need to take away the trapezium. So let's check this trapezium area. So we need to first, we know this is 2, this is minus 4, so we need to plug in the x coordinate into the tangent equation, which is y equals minus 2x plus 7, y equals minus 2x plus 7, to find out the y coordinates. So that is y equals, when x equals 2, that is 3. When y equals minus 4, that gives us minus 8 plus 7, no, sorry, it's not minus 8. It is 8. 8 plus 7 give us 15. So we know this is 3, this is 15, and the height of this trapezium is 6. So the area of a trapezium can be calculated by adding 15 plus 3 over 2 times the height, which is 6. So actually we're calculating 18 times 3. That gives us 54. The enclosed area was 100, the shaded area R is 162. Take away 54, that gives us 108 exactly. So we have proved the shaded area is 108. We used a lot of technique, including differentiation, integration, polynomial division, but you don't have to do that. That is only one of the methods. And some analysis, drawing, sketching a graph, finding the area of a trapezium, and then using the algebraic method, we finally prove the answer, finish the question. I hope you understand the solution, enjoy the video, and see you in the next.